Film here. Today's session will be about the significance, or looking at the significance of one Earth's axis, as well as the significance of Earth's revolution around the sun. Why that is important, that's what we're going to be looking at, right? So, as the information states here, the Earth's axis and its revolution around the sun have profound effects on the planet's climate, seasons, and day-night cycles, or day and night cycles. In other words, the Earth axis, the position where the axis of the Earth are situated, it makes a huge impact on our Earth's climate and our seasons, winter and summer, and of course, it dictates or it dictates the day and night cycles. Okay, so what we're going to be looking at here, we'll be looking at the breakdown of these elements that we've just talked about as axes as well as the revolution. But of course, we're going to start with the axis, right? Now, the first point here, it's the tilted axis. So, the x-axis is tilted at an angle of approximately 23.5 degrees relative to its orbit around the sun. This tilt is crucial for variation in sunlight received at different latitudes throughout the year. In other words, let's look at this depiction, right? Depiction A is not the appropriate or the correct axis of the Earth. In other words, axis omhlaba awasuki from north straight all the way to south pole, right? Awamili kanje straight. In other words, this one is not the correct depiction of the Earth's axis. Instead, this on depiction B, these axes that are noted with this dashed red line are the appropriate axes, which are angled 23 degrees relative to the Earth's orbit. Now, this tilt is important in receiving different sunlight throughout the Earth. Now, this is also an example of a globe. A globe nebuka lapho ukuthi ama-axes akhona awasuki from here all the way to here, but asuka from here all the way to here. They are tilt. So in other words, indlela ilanga elifika ngayo la ku-equator alifani nendlela elifika ngayo la kuma-poles because of this tilt. We're going to look at it in more details in future lessons. Now, the second part are seasons, right? So the tilt of the Earth's axis results in changing seasons. As the Earth revolves around the sun, different parts of the Earth receives varying amounts of sunlight. In other words, when the northern hemisphere is tilted towards the sun, it experiences summer, while the southern hemisphere experiences winter, and vice versa. Now, this point, because of the tilt, it is said that in the northern hemisphere, if the tilt is facing the sun, that hemisphere is going to be receiving summer. That's that. If the tilt is towards the sun, that hemisphere is going to be receiving summer. But on the other hand, while southern hemisphere experiences winter and vice versa. And don't worry in understanding this northern hemisphere winter, northern hemisphere summer. We're going to explore into it as we move on. But the tilt, Earth's tilt, is causing the crucial importance in the amount of the sun received throughout all the latitudes. And also this tilt also helps differentiating the seasons, or rather making northern hemisphere summer while southern hemisphere winter because of this tilt. We're going to look at it though as we move on. Moving on to this point, this depiction shows, of course, the Earth's rotation, and that it is rotating from the direction of west all the way to direction of east. It's not either way around. indlela umhlaba rotate ngayo rotate from the east direction all the way until the east direction. Now that is important, or it will help us understanding some of the information as we move on. Okay, so now let's look at this depiction. It's an annual cycle of our seasons. It's an annual cycle of our season. Now, this is in order for us to understand this, let's look at the colors that are written. So it's written in green, a color, and also in blue color. Now, what does that mean? According to this depiction, for simplicity or for explanation purposes, all the green colors are denoting anything to do with the southern hemisphere. All the green colors are denoting anything to do with the southern hemisphere. In other words, here, winter, southern hemisphere, that's what it is. Spring begins, southern hemisphere, and so on and so forth. Whereas on the other hand, blue color denotes or explain everything and anything that is happening on the northern hemisphere, right? So of course we are looking at the cycles of our season, right? Disclosure: this is not in scale. In other words, the distance from here, from the sun towards here, it's not the actual distance, right? So this is for demonstration purposes only in this particular case. Now, let's look at this. Start with the northern hemisphere, summer. Now we see the sun here is at the center, of course. Now the north pole of this side. The north pole is facing, as you can see, is facing towards the what? Towards the sun. That is why it will be receiving summer. Whereas on the other hand, the south pole is facing away from the sun. That's why it's going to receive what in the winter. So when it is winter in the southern hemisphere, in the northern hemisphere, it's summer. It goes all the way around. So we're going to be looking at this depiction right here and also this depiction right here. On the other hand, right here, we see the north is no longer now facing towards the sun, but it is facing away. In other words, it's now far from the sun. Of course, that is why it's going to be receiving winter. That's why it's going to be winter in there, right? And then vice versa in here, the south party is also facing, but it is facing sun in this particular case. That's why it's going to be receiving summer seasons. Right. Now, on the other hand, there are these other seasons, basically, right? So let's move on and look at because remember we have spring, summer, autumn, and winter, right? So please go on this or look at this step by step, starting, of course, with only northern hemisphere, and finish with it. Go on to southern hemisphere, and finally southern hemisphere, right? But yes, this is where we are. Spring begins in northern hemisphere. If the earth is in this particular position, the spring has now started. For which hemisphere? For northern hemisphere. From spring, of course, you go to summer. Spring, summer, autumn, and of course, winter. This is the northern hemisphere right there. And of course, same things apply with the southern hemisphere. It starts here for southern hemisphere, right? Spring, from spring, summer, from summer, autumn, from autumn, winter. That's the understanding right there. Okay. That's that, by the way. As far as these explanations happen. This is basically the cycle of the seasons throughout the year. Okay. But of course, all of this is determined by the tilt of the earth on its axis. Okay. Moving on to the third party. Here are day, or rather day length. Yes. So the tilt also affects the length of the day and the night, right? So during summer, the days are longer and the nights are shorter, while during winter, days are shorter and nights are longer. All it is based on the tilt. Moving on. So, where are we now? We are on the revolution around the sun. Hey, number one, orbital path. What we're saying here is that the Earth's revolution around the sun takes approximately 265.2 days. That is defining period of 1 year. Now, the elliptical shape of the Earth or of the Earth's orbit results in varying distances from the sun throughout the year. So the point is, there is one point in the year whereby, as you can see, the distance here, whereby the Earth is closer to the what? To the sun. We also have another time within a year, whereby, of course, the Earth is closer to the sun. In this particular regard, on this particular way, kule session le noma kulesi sikhathi lesi umhlaba uzoreceive ilanga kakhulu, and uma ikule session, of course ilanga lizoreceive kancane on the what, on Earth on that particular time of the year. Okay, but the understanding is that is elliptically a shape in which the Earth is orbiting its axis. In other words, it doesn't orbit the Earth in a rather perfect cycle. It is in elliptic shape, which that particular shape determines the energy received at this particular point, and of course energy received at this particular moment. Right? Moving on here, we also have equinoxes or equinoxes, as well as solstices, right? Now, equinoxes, solstices, equinoxes in here occurs around March 21st, as well as September 23rd. Now, in this particular point is when day and the night are approximately equal in length. Lapha kwi-equinoxes kulapho khona usuku kanye nobusuku bulingana in length. Okay, bese kuba ne solstices eyenzeka around June 21st to December 21st. Lapho ke appoints when one hemisphere specifically experience its longest day. We call that, or it is called the summer solstice, or a hemisphere where one side of the hemisphere its longest, or rather experiences its longest night, we call that winter solstices. So, in conclusion, or in summary, solstices to one hemisphere whereby it experiences longest day, or it experiences longest summer. Longest night. That happens around 21 June and 21 December. Whereas equinoxes are points where one night, or rather a night, as well as the day is approximately equal in length. So that's it. Moving on to final point under here, climate zones. So the combination of Earth's tilt as well as Earth's revolution around the sun creates this unique climate zone, such as tropically temperate as well as polar areas. So what does this mean? It means that because of the Earth's tilt, indlela ama-axes omhlaba otshele ngawo kanye nokurawunda kwelanga umhlaba wonke, lokho ku-create ekutheni kunezinye zindawo okubanda khona kakhulu, kunezinye zindawo lapho kushisa khona kakhulu, noma singasho ukuthi-ke kunezinye zindawo lapho khona receive khona more sun, which means those areas are going to be hot. Kunezinye zindawo receive less sun, which means those places are going to be cold. All of those things we're going to explore them as we in a more detailed manner as we continue. Right. So that's that for these particular points. Finally, overall, this is a repetition of everything that we've just said here in the overall impacting toward the interplay between Earth's axial tilt as well as the revolution around the sun creates that diverse and dynamic climate system that supports life on our planet. These factors drive weather patterns, also influence ecological system, and play a significant role in the natural world. Now, this is basically the repetition of what we've just said, ukuthi-ke indlela umhlaba ome ngayo kanye noku-rotator wawo, revolutionizer around the sun, it basically influences our weather patterns, ecological system, natural world as well. So basically, we're saying some other places are cold, some other places are hot. So that's the understanding, which is caused by all these things that we've just talked about. Earth's axis and its revolution. Okay, now this is the time where you test your own knowledge here on multiple choice to make sure you understand everything in here. If you don't understand everything in here, of course, it means that you didn't understand what was being discussed on that lesson. So it means go back, restudy it, watch it, rewatch the video so that you will be comfortable. So that's that for now, as you can see. And then at the end, we have model answers as well that are going to help you, correct yourself in here. So that's that for now. Thank you for watching and bye-bye.